Okay, we would like to solve the 2 by 2 system for u sub x and u sub y. We have u sub r is u sub x cosine theta plus u sub y sine theta from the chain rule. And v sub r is u sub x sine theta minus u sub y cosine theta. And we're just going to use the standard method of elimination and substitution to solve this system for u sub x and u sub y. So first what we'll do is we'll multiply the top equation by sine theta and the bottom equation by cosine theta. So we'll multiply the top equation by sine theta and we'll multiply the bottom equation by cosine theta. And that way we will have the exact same first term on the right hand side of both equations. Both equations will have u sub x cosine theta and sine theta. U sub x cosine theta sine theta. So if we do this, we have for the top equation u sub r times sine theta equals u sub x times cosine theta times sine theta, and then u sub y plus u sub y sine theta times sine theta, so sine squared theta. And the second equation will be v sub r cosine theta equals u sub x cosine theta sine theta. And we'll notice that these two are exactly the same, and that was the reason for this choice at the beginning. And then minus u sub y cosine theta times cosine theta, which is cosine squared theta. So now that these two are exactly the same, we will subtract. And we get u sub r sine theta minus v sub r cosine theta is equal to, if we subtract, this term minus this term just completely cancels, and we get this term minus this term. So u sub y sine squared theta minus negative, so plus u sub y cosine squared theta. And now if we factor out u sub y here, we have sine squared theta plus cosine squared theta, which is 1 in the parentheses. So this is just u sub y. And we have half of our answer we would like to solve for u sub x and u sub y. And we have u sub y is equal to u sub r sine theta minus v sub r cosine theta. So that's half of the answer. We could repeat this procedure, canceling the u sub y's, by multiplying the top equation by cosine theta and the bottom equation by sine theta to make the u sub y terms exactly match, and then get u sub x. But instead of doing that elimination, let's find the other term, u sub x here, by just doing substitution. So if we just take the top equation, say, and we substitute u sub y in here, then we should be able to solve for u sub x. So let's just do that here. U sub r equals u sub x cosine theta plus u sub y sine theta. And u sub y is in the box here. U sub y sine theta. U sub y is u sub r sine theta minus v sub r cosine theta. So that was u sub y and then sine theta. And now we'll solve this for u sub x. It looks a little bit complicated, but it turns out nicely. So u sub r is equal to u sub x cosine theta plus u sub r sine theta times sine theta is sine squared theta, and then minus v sub r cosine theta sine theta. So since we want u sub x, let's move the other terms to the other side. So we have u sub x cos theta is equal to u sub r. Move this one over, so minus u sub r sine squared theta. And then move this one over, plus v sub r cosine theta sine theta. Now here, if we factor out u sub r, it's 1 minus sine squared theta, which is u sub r times cosine squared theta. And so we have u sub x cosine theta is equal to u sub r cosine theta, cosine squared theta, plus v sub r cosine theta sine theta. And then the result will follow by just dividing both sides by cosine theta, so that u sub x is equal to u sub r cosine theta plus v sub r sine theta. So u sub y and u sub x.